Hello everyone. Through this video, we are going to discuss a very special topic in the subject of mathematics. This special topic is nothing but permutation and combination. This is all about counting, which every one of us does in day-to-day life. People often find it very difficult, very confusing to get into the theoretical concept of permutation and combination. But when we relate this topic to some real life situations, then the concept becomes a bit easier. In mathematics, there should always be some accurate answer for every why and how. If we gradually step into this field of permutation and combination, relating this to the practical situations, then it will be easier for us to evaluate every how and why. So let us begin. Now let us relate permutation to a real life situation. All of us use ATM cards. Yes or no? You also know how to use ATM cards. Our parents, then everyone in our family are often found using ATM cards. Now, ATM cards can be used, actually, money can be withdrawn or deposited through a particular PIN number only. The main thing in an ATM card is nothing but the PIN number. Initially, when we open an account in a bank, they provide us with ATM cards along with a secret PIN. These PINs are found to be 4-digit numbers. Yes or no? 4-digit number. Suppose two persons are having accounts in a particular bank. Now, while providing ATM cards to these two persons, the bank will take care of one thing, that they should not be having the same PIN for their respective ATM cards. The PIN that is provided by the bank is always machine generated. So the PIN numbers when we are provided through the bank are always machine generated. The machine is designed in such a way that it can provide us, means every account holder of the bank, different PIN numbers. Means any two account holders of the same bank should not be provided with the same PIN for separate ATM cards. So while doing so, the machine actually takes care of the arrangement of the 4 digits with which the PIN number is generated. Let us check what is written here. While creating a 4-digit ATM PIN, the arrangement or order of the digits is important. Actually, already I told you that when the machine generates the ATM PIN, it always takes care of one thing, that no two ATM pins should be same. So, if suppose only 4 digits are provided, say 1, 2, 3, 4, the machine is used to generate PIN numbers. In that case, the machine takes care of the arrangement or order of these digits. 1, 2, 3, 4, then after again it may be 2, 1, 3, 4, then again it may be 4, 3, 2, 1, in that way. That means no two numbers comprising of these 4 digits should be same. That means 1, 2, 3, 4, then 1, 2, 3, 4 should not be for two ATM cards. So what is the main thing to be taken care of here? It is arrangement or order of the digits provided to the machine. Now, what is said here? Let us consider that 1, 2, 3, 4 are the digits with which the ATM PIN is to be generated. It is known to us that for two persons having account in a bank, the machine cannot generate the same PIN. Already it is discussed. Therefore, while creating the ATM PIN, the arrangement or order of the digits matters a lot. Means in what way the digits are organized, the digits are arranged, that matters a lot. In other words, Though the same digits are to be used, the positions of the digits should vary. That means if suppose for the first pin the arrangement is 1 2 3 4, the second pin should be a bit different. That means position of the digits should be interchanged. That means what is said here, that means the pin 1 2 3 4 is different from 4 3 2 1. Yes, of course the positions are different, that is why the pin number is also different, which is again different from 3214. The total number of possible ways to generate pin from these four digits refer to the concept of permutation. That means, what does it mean? From this example, we came to know that permutation is all about arrangement or order. The position of the digits matters a lot. That means arrangement of the digits matters a lot here. Therefore, permutation refers to arrangement. Select and then arrange. After that, let us relate combination to a real life situation. Now, we often find students after completion of class 12 course, they go for admission in colleges, different institutions, etc. The first thing they have to notice is what? Subject combination. Suppose a student is trying to get admission in degree college. He is taking three options. Often we find students taking 2 3 options for getting admission in any institution of his or her choice. Now, in this case, in our example, let us consider that the student is taking three options in his hand, say three colleges A, B, and C. In which college or institution he is going to apply first, that doesn't matter. He may apply in the first college, I mean in college A also, he may first apply in college B also, or in C also. It is necessary that he has to apply in all the three colleges, means three among all the institutions of his city. He is selecting three options. Now, which option will come first? That doesn't matter. Just the selection matters. He is opting for college A or college B or college C. Suppose if he is going for college C first, then after comes to B, then after he is applying in A, that will make no difference. He may follow the order ABC also, BCA also, ACB also. Any of these orders he can follow. So the thing that matters here is selection of the options. Means among all the colleges in his locality, in his area, he is keeping three options in his hand. That means he is making three selections here. So arrangement is having nothing to do here. It is all about selection. Now let's look at this example. What is it saying? So what is said here? After completion of class 12 course, students are found applying in different colleges and institutions of their choice. Yeah, this is quite obvious. Each student keeps 2, 3 or more options with him or her for carrying further studies. Now let us consider that a student is planning to apply in three colleges, namely A, B and C, for further studies. Okay. In which college he is going to apply first, actually that doesn't matter here. That is what I explained to you just now. That means he can apply first in A also, B also or C also. Actually the arrangements like ABC or BCA or ACB makes no difference amongst themselves. The only thing matters is selection of colleges, not arrangement, and this leads to the concept of combination. So that's all about combination. So till now what have we understood from these real life situations? Permutation refers to the concept of arrangement, while selection leads to the concept of combination. In combination, arrangement has nothing to do, but in permutation, after selection often we make arrangements, because in this example of permutation I have chosen these 4 digits. Actually, selection has already been made. After that, what matters? Arrangement. How we are arranging these digits, that makes the concept of permutation. Now, the next question that will arise here will be, why do we have to study such concepts? What is the necessity actually? If we do not study these things, then also everything is okay. Why do we have to study these concepts? Let us know here. The concept of permutation and combination is all about counting. In the previous part only, I explained to you that the entire concept of permutation and combination is based on counting. The very term counting refers to a huge area in mathematical platform. Yes, mathematics is all about counting. Now, thing is what? Human minds are capable of counting only a few things. Like when the data is small, then we can count the things or calculate things. But for large data, will it be possible for us to count? Therefore, mathematicians in course of time, after lots of research and studies, developed the concept of counting. Means they tried how to make counting a bit easier, and ultimately their efforts satisfactorily reduced the different problems of counting. This gradually occupied a great portion in the field of mathematics. Of course, since this part is working, this concept of counting is working a lot, it has to occupy a big portion in the field of mathematics and develop the necessity of studying this as an important topic. So this concept of counting refers to the concept of permutation and combination. That means the concepts of arrangement and selection. Nowadays, this is a great topic in the field of mathematics. Now let us know about the specific utilities of permutation and combination. Let us first look at the utilities of permutation first. What utilities we find here? Actually, permutation is used for arranging people, arrangement. There is a word arrangement. So, where there is arrangement, there is permutation. After that, arrangement of numbers. Here also we of course have to use permutation, concept of permutation. Then arrangement of colors. There also permutation is required, means the fields, means the practical situations where we have to arrange the things, we have to use the concept of permutation. After that, let us come towards the utilities of combination. While going to restaurant or anywhere where you get food, we often find ourselves selecting menu, then foods, etc. Again, we often find students in colleges, schools, universities in selecting subject combination. I already have put forward an example also on a combination of subjects. So these are the real life situations where we find utilities of permutation and combination. Now, why the terms permutation and combination are used together? The main reason behind this is what? If we learn permutation separately and combination separately, then also it is fine. But if we know permutation only and not combination, in that case, we may have to face some problem sums in which both the concepts will be found. Means there are some problem sums, some questions on this part of counting which will involve both permutation and combination concepts. That is why, to know this concept of counting entirely, we have to study both the topics. Let us now learn the combined utilities of both. Basically, in cryptography, then network security, communication network, design of computer chips, etc., both permutation and combination are found getting involved. So these things are having maximum importance in day-to-day life, and the basis of all these things are based on permutation and combination concepts. Both permutation and combinations are used in these particular areas. Now let us know what is the basis of the concept of permutation and combination. Most interestingly, the entire story of permutation and combination, that means arrangement and selection, is based on fundamental theorem of counting. This is a new concept again, fundamental theorem of counting. Before getting into the subject content of a permutation and combination, we must have to know what is fundamental theorem of counting. In my next video, this will be discussed. Fundamental theorem of counting will be discussed. Now let us go through a simple example. This example will show us the concept of permutation combination separately and analytically. Till now, we have gone through the real life situations of permutation and combination, means involvement of permutation combination in real life situations separately. Now we shall try to visualize this through some analytical point. So let us look at this. To the top of this figure, let us consider that we have three numbers of markers. We often use markers while writing in whiteboards, from which we want to select and arrange two markers out of three markers. That means we have three markers in our hand, out of which we have to select two markers and then arrange. Now its diagrammatic representation is given here. The markers are these three. One is pink colored, one is blue colored, other one is yellow. Now case 1. The first case is what? From these three markers, I have drawn two. One is pink, other one is blue. Again, while arranging these two markers, once I can put the pink one first, followed by the blue one. At the same time, just after that, I can place the blue marker first, then after the pink one. So out of this, I got two arrangements. Similarly, coming to case 2, this time I have selected two markers, last two markers, that means the blue one and the yellow one. Now these two markers I can arrange in two ways again. The blue one I can keep first, followed by the yellow one. After that, at the same time, I can keep the yellow one first, followed by the blue one. Again, I got two arrangements. Then coming to case 3. This time, I have selected the third marker and the first marker. That means the yellow one and the pink one. Keeping these together, I have to arrange it once again. Again, two arrangements can be done out of this. So yellow one, in the first part, yellow one I am keeping first, followed by the pink one. While just after that, I kept pink one first, followed by yellow one. Once again, I am getting two arrangements. So what is the thing to be noticed in this case? First time, in each case, I am doing what? I have selected two markers each, followed by two arrangements in each case, where the positions of the markers are just changed. That means here in this case, there are occurrence of two cases, two main parts. First selection, then after arrangement. Again case 2, selection and arrangements. Again in the third case, selection and arrangements. So out of this, two arrangements plus two arrangements plus two arrangements, in total I'm getting 6 arrangements. Out of how many selections? Out of 3 selections. So this gives rise to the concept of permutation. That means 6 arrangements are done from 3 selections, and this gives rise to the concept of permutation. This implies the concept of permutation. While coming to the right hand side of this figure, we already have 3 numbers of markers. Only we have to select 2 markers out of 3. This is all about selection. So diagrammatic representation is given here. These are the three markers, the same position, same colored markers we are taking, one pink, one blue, one yellow. Case 1, in the first case, we just have to select 2 out of these 3 markers. So in the first selection, I have drawn one pink and one blue marker. In case 2, I have selected the last 2 markers, I mean the second one and the third one. That means blue marker along with the yellow one. This is the second selection. Again, case 3, I have selected here the last marker and the first one. That means yellow and pink. So this is the third selection. So in total, we do not have to arrange it, just we have to select. 2 markers are to be selected from this tree. So how many selections could we make? 3 selections. We are making 1 selection plus 1 selection plus 1 selection. So 3 selections are made, and this will give rise to the concept of combination. In other words, this is implying the concept of combination. Through this video, we are trying to make you familiar with the basic concepts of permutation and combination and how this can be related to real life situations. Thank you.